this is my example for the force table, and I filled water in these bottles. I put 235 grams in here and measured it, and this one is going at 270 degrees. And I put 495 grams into this one, and this one here is going at 180 degrees. I'm not going to let them hang right now because it's not going to be stable. I need to have everything set up at once. And this one here to show you how I measure this one here. So I'm going to determine how much mass it has, and I have to tear it in the vertical because that's how I'm going to hold it. So here we go at 0. And so now I'm going to tie this around here. And this kind of string here is going to hold on to the lid. This is actually my second or third take, and I noticed that this thick string later on for the experiment itself will not work. It's going to work just fine for determining the mass. But in fact, there it slips a little bit. 175 grams is what I have, so about 1.75 newtons. But if I tied it to my experiment here itself, it exerts too much friction, and so I don't. I use string that will have much less friction. Okay, and now it gets interesting. So here goes my first bottle at exactly 0 degrees. So this is the 175 grams mass, about 1.7 newtons. Here is the 235 grams, or about 2.3 newtons. And then, I left the spring scale over there. Thank you. Everything will start slipping on the metal. I think it already did. Okay, let's see what I get here. I have to make sure that everything is
horizontal tear.
Yeah. Oh yeah, I have to pull in this direction here to hold it. And then actually I just noticed something. I need to retie this one over here because the knot is slipping, so I only made one knot in there. So I guess you could keep taping. This is, after all, troubleshooting. So this is how you tie a knot, right? Yeah, that wasn't too bad. Okay. There we go. Now I ran into a different kind of problem. My string on one side is too short, so I need to retape this one here pretty much in the X direction this way and then the Y direction this way. I actually don't have to use the middle of the table, but what I have to pay attention to is that these are aligned with the horizontal, I mean the X, and this one here with the Y, and then this one here goes off perpendicular, and so do the other two. On this particular table that I choose, I actually have a groove in the middle which tells me the X direction. I tried to do this with pulleys and putting them on Play-Doh. I have these over here, but it turned out, well, it could have produced too much static friction in there. So I'm just trying the beveled edges of this table here and see how this works out. And so now I'm ready to measure. So what you're seeing here, of course, is the kind of troubleshooting that you might have to do. And then, of course, I have to pull it in just the right direction, so apparently not in this direction, but somewhere over here. So I want to say I'm at 30 some degrees, 33 degrees is what I'm reading. That seems to be my best angle. Yeah, if I pull over here it's not going to work, so it has to be, yep, about 33 degrees. And I'm measuring approximately 3.7 newtons. So of course I'm measuring the force here. Over here I have masses, but they themselves are weights as well, so I have to eventually convert those to newtons. And I'm going to take my string here and a little bit more in the middle there. And yeah, that's what I got. 33 degrees, and what did I say? 3.7 newtons. And that's my example. I'm going to make example calculations with that, and then of course you're going to make your own measurements with the numbers given to you. Okay, thank you.